Let's try. Is it your adapter?
Yeah,
or
yeah. It worked this morning.
I think. Three, two, one. Can you check your microphone, please?
1, 2, 3.
Perfect. And please welcome Hynek.
Hello. Okay, I'm Hynek. For those who have seen me last year, I taught you how to take 5 weeks of vacation. I hope every one of you have tried that. It's really great. This year, for a change, I want to make your life easier every day, like in general. I want to make it easier by doing less. And I want you to stop worrying about a lot of things in your applications. I want you to stop worrying about where your logs go and how they are processed. I want you to stop worrying where your configuration is coming from and how it's structured. And I want you to stop worrying where your application is running and how it even got there. And instead, I want you to start to think about how your application could play nicely with others. Because those tasks I've just enumerated, of course, do not go away. Someone still has to do them. But if you stop thinking about your applications as a Python and Django app that serves cat pictures, and instead start thinking about it as a universal building block with a consistent interface that runs somewhere, others can do that work. So you can outsource complexity that is not inherent to the value of your application, which is kind of cool, because you can focus on the parts that are important. And as a side effect, by the end, your application is going to be web scale by accident, or cloud native, how the kids like to call it nowadays. Now, as with actual building blocks, it shouldn't matter whether you are building a doghouse or an airport. And I'm from Berlin, so I know everything about building airports, believe me. And yeah, this is funnier if you know the history of Berlin's airport. The joke is we don't have one actually right now. Or we are building one for 15 years and it's not going to be anytime soon done. So your application should look the same and feel the same on a laptop and in a cluster. And that dramatically simplifies your development process, the testing, operations, scaling out, and moving to new platforms. And while that may sound academic first, platform agility is a much bigger deal than you may think if you think further than like 2 years out. Because every infrastructure evolves over time unless it goes extinct. So you will have to touch that CentOS 5 server eventually, as will I have to. So even if you're happy nowadays with your state-of-the-art Kubernetes cluster, in 5 years, there's going to be a really good business model on helping people to move off this legacy tech debt platform. So how do we get there? And what exactly do we gain? And I will show you with a very, very simple web application. But the talk is not really specific to web applications at all. It's specific to long-running services that need to be exposed somehow to someone. And while I'm talking meta, as with every of my talks, there's going to be a link at the end that lists all the links and all the concepts that I'm talking about, so you don't really have to write a lot of down. But now, behold our application. This is a very exciting pyramid view, and I would just like to know how many of you have used Pyramid? Okay. Just how many of you have used Falcon? Okay, how many of you have used Flask? Oh yeah. JetBrains was not lying. Right. So imagine it's the same. It does not really matter here. So in order to run this pyramid view or web view, in order to expose it, you need to wrap it in a WSGI application. And how you do that really depends on the framework. This is how you do it in Pyramid, but it looks about the same in every web framework. In Flask, when you start using blueprints, you're doing almost the same thing. And it's usually a function that does something and returns something else that you can pass into a Whiskey container or into a test framework. I like to call it make app because it makes an app. And I like to call it into a file called app maker because I like descriptive names. So this initialization code, once it gets more realistic, is notoriously hard to test. So the goal should always be to keep it as simple as possible with as few branches as possible between test, development, and production. Because it's hard to simulate those changes. So, and this principle, again, is not specific to web and Whiskey. So you always have to isolate the creation of your application. Right? This is where you wire up your app and configure it using classes and functions and whatnot. And this is kind of the interface to the environment. So in Pyramid, you build up a configuration object by creating it, calling a few methods on it, and then you call make Whiskey app, and it will transform the information into a Whiskey app. A Whiskey app is actually just a function. You may have seen it in some examples, but that's really not important here. Important is how we use it. So I'm going to use Unicorn, which is a really good Whiskey server. And you just tell it to call this function for you. And that's it. It comes up. You can curl it. And you even get log entries in Apache format. Now, if you wanted to deploy it just like this, your choice of Whiskey container, in this case Unicorn, and its options and all this kind of configuration would bleed into your configuration layer, which may be a different repository altogether, maybe your Ansible repo or whatever you use to configure your clusters. So this is not great. And maybe you want to leave Whiskey altogether and move to AIO HTTP. By the way, how many AIO HTTP users? Oh yeah, we are in the East. So, for the record, for the video, it was almost as many hands as for Flask. I'm proud of you. So, again, this is very specific to your application, how it is right now. If you want to switch out the Whiskey container, you have to change the application dependencies, you have to change the configuration. If you want to move to AIO HTTP or something, you have to change everything. So it's kind of inconvenient that you have to coordinate changes between two places, because that always means there's some room for errors, and you want to avoid that. So let's zoom out. We want to have a building block, right? So we want a standardized way to start up your application, no matter what is inside. So it could be C++ for all we care. So how do we do that? Well, we do what our ancestors did in the 1970s. We write a shell script. And this shell script, we just check in along with the application, which means that the choice of the technology you're using and the way you start it are in the same place. Now, I want to point out a few things. First is exec. This will replace the shell process with your own process, which is super important if you want to receive signals, which you do. I will point out a little bit more about it later. And this cryptic part here means that the standard error output is redirected into the standard out error, which gives you one stream of logs, which is much more convenient to handle in practice. So in this way, your shell script becomes an adapter between your application and your environment. And this works just fine in systemd, in Docker, in proc files, which you may or may not know. It's a way to configure multiple services at once and run them. The first one to support it was Foreman, but there's also Forgo and Honcho, which is written in Python. It's just very useful in local development if you have an application that consists of multiple parts. But it was mostly famous because Heroku uses it internally. So if you define services or used to define services in Heroku, you had to write a proc file. Now, what do we have at this point? We have our black box, the application. I'm going to argue this is a building block that is very easy to run because you just run a script. It serves a local host, and it logs to standard out. And this is great, because at this part we are done. Because logging to standard out means that you get your logs in your terminal in development. If you put it on a normal server running systemd, it gets forwarded to syslog, which means that you get 40 years worth of Unix log management tools at your disposal, which is great. You don't have to reinvent that. And if you're running something more modern, like a cluster manager like Kubernetes or Nomad, they all have first-class support for standard out catching, and they will allow you to stream the output to your terminal over the network, or help you aggregate it in something like Logstash or Graylog. Now, I would like to implore you to not to log to files, because it makes everything just more complicated, and especially do not rotate them yourself. There are great tools out there which are always great for the environment they're running in, and doing this in Python is just a constant source of pain. Now, I'm going to argue this has very clear interfaces. You know what's going in, you know what's going out. Now, in the next steps, we are going to use this application and add more features to make it more realistic, more useful. But we will try to always stay as close as possible to this ideal. So first, let's tackle the most glaring problem, which is exposition. You can work around the fact that you're always serving on the same IP and same port, but it's not super convenient. So let's shed those shackles and talk about configuration. And I think it's important to stress the difference between configuration as it is used for general purpose software like Apache Nginx or Postfix, which has to work for everyone with very varying needs, which is very different from your application which you are putting into production, which has to only make happy you. So what you need to ask yourself is not, what can I make configurable? What you need to ask yourself is, what varies? What varies across deployments? What varies across environments? And it turns out that's very, very little. So there are things that just do not belong into a configuration that some people still do put there, like the routes definition, the middleware, or logging. I'm going to argue with you that the external configuration of logging is not great, because what you really want is just two switches that you need to, or two knobs that you need to turn. So first is the format. You want two formats of your log. You want something nice, human readable with colors when you're locally developing and reading it, human readable. And you want something easily parsable that you have on your servers, that you can aggregate, that you can parse, right? So, right? And then you need a log level. You probably want something more verbose in development and something more sparse in production. Well, you can just put two configurations for logging in your application and then switch using simple key value pairs. And that's it. And now you can test your configurations in your app, because the configuration for your logging does not live somewhere in a completely different repo. It's the same problem again. You don't have to copy-paste your production logging configuration over just to check that you didn't forget a brace somewhere. So what does vary, though, is exposition very often. Like the thing where your application on what port and what IP it's listening. Also, external resources, things like web APIs or databases. That's things that you need to tell your application about how to access it. Now, once you've identified those few options, and it's usually just a handful, even for very, rather complex applications, you need to pass them into your app. So how do you do that? You could put it into a .ini file. It's easy enough. Python has ini file support in a standard library since forever. But unfortunately, there's plenty of environments where it's hard or even impossible to inject files. And also, if you look at those options, some of those options are for your application, and some of those options are for your whiskey container. And you shouldn't have to care about what lives where when you're writing your config. And you don't want to parse ini files in bash. I know people have done it before, but you don't. So what we really want is simple key values pairs passed into your application. Now, do we have something like that? Do we have something that is simple, reliable, and portable? I did not pay him for that. Yes, it's environment variables. They are back. And they do not work just for the simplistic problem. They are universally supported, so like systemd, for example here. Docker, of course, has first-class support for environment variables, and every single cluster manager under the sun has first-class support. Now, there's also a lot of tools around that. So direnv is one of a billion tools that will set certain environment variables when you enter a directory. Every service discovery and key value store has a client that allows you to transform their server information into environment variables. So the one is for console, the other is for etcd. If you want to consume environment variables, every language has support for that. For Python is os.environ. If you really need a file, which can happen, there is env-zapst, which is part of the get text translation project, which will allow you to do very simple templating based on text files and environment variables. So you can have files, but those files should not be coming from the outside. That's what I'm saying here. So turns out, there's one more. There's even more powerful tools like console template, which has using Go templates, which are not great as Jinja, but they work, and confd, which supports even more backends. So you can take values from Redis and write them into environment variables. So this is kind of cool. So let's talk about our host and our port problem. So it turns out people had this problem before. And it's so common that there are standard variable names. And they are very appropriately called host and port. And conventions are great. The aforementioned foreman, for example, will enumerate ports if you define multiple apps using those variables. So if you define 3 applications, the first one will listen automatically on port, I think, 5000, the second one, 5100, and so on. You do not have to enumerate them by hand. So conventions are great. If you are writing something more bespoke, but need to configure host and port, I would suggest that you support a standard. Now, the log level is easy enough. You set it on a variable, then you do a little bit get-attr magic and os.environ, and it works mostly. Now, fuzzing around with os.environ is tedious, it's ugly, and this is like the most super global state you can ever have. And it wouldn't be me if I gave a talk without plugging another project of mine. So let me introduce you to environ-config. I know there are more projects by now on PyPI that do similar things, but none of them did this when I started this project. So let me give you a very quick rundown. So it allows you to declaratively define your configuration using classes. And as you see, those classes can be nested. So you define classes inside of classes. Now, when you load your configuration, it will just concatenate those names into a variable name and read it from the environment. And you can then access those values using like normal nested class instances, the law of Demeter be damned. And since it's based on adders, there's a bunch of things you get for free, like default values, validators, or converters. I really like to limit the valid values for certain options using enums. This one I like to put into a file called config.py because it's config. But just by declaration, those values are not loaded because I don't want to have to this side effect from importing it. So where do we do it? We could do it in make-app, which I showed you before, but I do not like that because I want to be able to use make-app in tests. And if make-app accesses os.environ, it gets very painful to use. So let's create a new file that does all the dirty work and then just passes an instance of app config into make-app. And this one I like to call whiskey. Again, I did not invent this name. This is quite common. And whiskey is going to be the only file that has import side effects. So it will do something when being imported. And now this module is the ultimate interface between your application and environment. And the make app functions I've shown you before that creates the whiskey app only deals with well-known Python classes, which is much more convenient and much less error prone. And this allows you to have the lowest common denominator on the outside, environment variables. And inside you have a validated structured data, which you can rely on. And of course, this is not specific to web or whiskey. You always want to have one very limited entry point into your application that does the transformation of the outside data into something your application understands. So this could be a CLI entry point, for example. These kind of things. Now, you may notice that I put my whiskey app now into a global variable called application. This has multiple reasons. So first, this is more flexible, having a variable, because not every whiskey container allows you to define the whiskey app based on a function call. This is quite specific to Geonicorn, if I remember correctly. And also, we need to pass an argument to make apps. So this won't fly. So in this case, we put it into a variable. We call it application because that's another convention. This is the common way to call whiskey applications. And this allows us to just specify the module where this variable is defined. So our run script got even simpler, which is great. Now, with all the excited talk about environment variables, there's one thing I conspicuously left out. And that is that time has shown again and again that certain things just do not belong into environment variables. Some things you want to whisper gently into the ear of your application and not make it a global value to your whole application process tree. There are many ways environment variables can leak. It happened before, it happened to bigger corporations, to smarter people. It will happen to you too if you take the risk. And it doesn't have to be your fault. It can be just some obscure third-party library that got into your application because some other library depended on it, and it just for some reason dumps the os.environ somewhere. Then you're screwed. So let's be very clear. Don't put sensitive data into environment variables. And I have to ask you to ignore the 12-factor app manifesto for now. I think they got this wrong, and I am not the only one who thinks that. And I think the only reason they didn't fix it yet is that Heroku doesn't have a great story around secrets. I don't know. So the problem is now things get hairy because solutions to good secret management are platform specific, and each platform has their best way to do that. And some of the ways also are cost money, so like you pay per access. So I have to just recommend you to use your platform's best thing and whatever you can afford, and leave it at that, because giving you a general introduction to all of this is a talk by itself. Luckily, this talk does exist. My friend Noah Kantrowitz gave it in 2016, and I will, of course, link it to it in my page. For completeness, we personally, we don't run our things in a cloud anyway. We run on-premise. So we use HashiCorp's Vault, which is free open source. And it makes you vendor independent. You can use it everywhere too. It's just more work. You have to run it yourself. Now, the safest way is always going to be platform dependent, and it's also necessary for dynamic secrets. For example, if you have certain credentials that change regularly and you have to query some service every single time. So what do? We have this platform-specific code, and what do we do in programming to hide away implementation details? We write a facade, and what I just do is that I wrap the secrets client, in this case this is the Vault client, in my own class. And now I have an interface. It's just called getDB URL. And this is what returns the URL to the database with all the credentials. And the application itself doesn't need to know what's going on and where it's coming from. And you can choose yourself. Do you want to load it on instantiation because it doesn't change? Or do you want to load it on demand? It's your choice. And if you switch your secret backends, you just re-implement this one class and you'll be fine. Of course, this also makes it very easy to replace with a fake when you're writing tests. You just return static strings and you're golden. Great. I'd like to point out here that I really like to encode credentials at URLs because so first of all, a lot of libraries already do support it, like the Redis client, SQL Alchemy, and there's also an extension for Django, which will allow you to do just that. And this allows you to change more than one part at once. So if you want to change the host and the credentials, like the user and password, and you save them in different parts, it can get, again, a bit error-prone to make sure that you always have a matching pair. So if you have it in one string, it's great. There's a lot of URLs for creating and parsing libraries. I like YARL from AIO HTTP, but there's many more, and you can choose whatever you like. Now, we still do have a nice building block that is easy to run. And we inject all the essential information that varies across deployments and environments. Secrets aren't as elegant, but with some effort, it's good enough. And we expose based on configuration, and we log based on configuration. Now, a keen listener may have noticed that with this setup, it's impossible to reload your configuration because the configuration is in an environment, and well, there are ways to change that, but let's stay realistic here. So I would like to reframe this ostensible downside as something good because it forces you to rethink it and you just embrace it. If you have something that changes frequently, make it dynamic and load it from a service. If it's something that changes, let's say, once a day max, well, just make sure that your deployments are fast and redeploy. And this makes you to think about zero downtime deployments very early on. And the earlier you get this working, the happier your life will be in the long term, because this compounds over time if you know that you can deploy anytime and you don't have to plan around it, you don't have to do anything. And the deeper you go, the farther into the lifetime of a service, the harder it becomes. So it's good to get this nailed down very early on. And thanks to our building block right here, it's also very, very simple. So instead of one application with the interfaces, we put two of them on the same host. We put a local load balancer like Nginx in front of it. This means your application will never have to listen on a privileged port at all. So you don't have to think about which, if you run it at root or if you have it some special capabilities. It's just not your problem anymore. You just listen on localhost and it's done. Now, your application's only new duty now is that you have to learn how to receive client information from the client. Like the load balancer has to tell your applications what the actual IP and maybe more information about the client. Now, if you're doing web, there's two standards. There's one that everyone supports but is not a standard, which is called X forwarded for header. You may have seen that. There's one that is standardized, which is called forwarded, but so far I think only Falcon supports it. And it's much nicer because it allows you to stack the whole path that the client accesses your app. So if you have multiple proxies in between, you can encode them all in those headers, but it's more work to get it work. Now, if you don't write a web application, but something like raw TCP, HA proxy has a special protocol for that called proxy protocol, and that will allow you to do the same thing. Now, at this point, we are ready for rolling updates. So if you want to change something about the app, you just tell the load balancer to ignore one instance. And now you can do whatever you want. You can stop your application without disrupting anyone. And to make this work smoothly, you need clean shutdowns. And this is the part where I will air one of my pet peeves. You have to make sure that you support sigterm. Not just sigint, which is Control-C, or keyboard interrupt. Sigterm is the standard signal for stopping processes on Unix. This is what systemd will use. This is what Docker will use. And if you fail to listen for sick term and just do the quite common try except keyboard interrupt, in the worst case, your application receives a sick term and ignores it. Now, the process manager will wait for a timeout, loses patience with you and your app, and sends a sick kill, which you cannot handle, which you cannot catch. So it means that you have very slow cleanup. No, you get no cleanups because you didn't catch the signal. And the shutdown is very slow because it has to wait for a timeout. So it's the worst of both worlds. Anyhow, assuming that you did the right thing, you listen for sick term, your application is down, and now you can take all your sweet time to deploy new code, to change configuration, do whatever you want. Now, once your application is ready, you just put it back into rotation. And this way, you leave the reloading of configuration to the load balancer. And load balancers are really good at this. And it's merging configuration state at runtime is a very non-trivial problem to solve properly. So it's really good to just outsource this problem to someone else, like HA proxy, for example. So another upside is that if your deployment doesn't go quite as planned, now what do? If your customers would be getting 502s or something, you would probably panic. But in this case, you do nothing, you just breathe. Because your application hasn't been returned to the load balancer, so nobody knows that you screwed up. So now you can take a sweet time to do a rollback or check whatever the problem is. You don't have to be like really nervous while your Slack is just exploding from your boss yelling at you. And so even if you deploy on production servers using git pull like an animal, you're laughing, I know some of you do. You still earn these benefits. This is not just for some amazing high-tech problems. It doesn't matter if you have some sophisticated cluster scheduler from the future or some underpaid intern with the SSH client. You will benefit from this. So, nobody will know. Before someone asks, data migrations, yes. I cannot help you with those. Data migrations are hard. If you need zero downtime with data migrations, there's only one way. You make your app in a way that it can handle both versions of data. Then you migrate the data, and then you remove the old version. That's how it goes. There's nothing that can help you with that. Now, there's one thing I hand-waved over, and it is when I said is added back to load balancing when ready. So how does your load balancer know that your application is ready? And for that, we are going to add another interface to your application. What we need is introspection. And introspection is a very, very powerful concept, and it's very easy too. So this is really nice. What you do is that you add a web endpoint that allows you to reach into your application, into the state of your application. And it does not matter what type of application it is. It could be some data science thing crunching numbers, because even the standard library has an HTTP server built in, so you don't even need an external dependency to have this. Now, the thing you need for your load balancer is called readiness. And it means that your app is ready to serve, that it's ready, that it is ready to be added back to the load balancer. So you expose a web endpoint that checks all the resources that it needs to serve your application. And this endpoint then returns a 200, go ahead, or 500, oh my God, I'm on fire. As for the name of this endpoint, there is no clear standard. You may have heard of Google's Health Z. I've heard multiple legends about the Z. So my favorite one is that it's Google Great Security by Obscurity, but it's probably just some standard to avoid clashes because they have more of those types. Then there's Dunder Heartbeat from Mozilla's Dockerflow, which is their standard on how they work around Docker containers, which is very Pythonic with its Dunder. And others are a little bit more literal. So this is Dash Ready, which is used by Prometheus, and Dash Readiness, which is used by GitLab. I personally love the Dash namespace, because it's super easy to block in your edge load balancer. So for example, if you use HA proxy like I do, this is one rule, one line, and then nothing can happen anymore. The downside of this definition of readiness, which is not from me, is that it's expensive. You have to ping your database, even if it's just a select one or something. So you shouldn't do it really every second, ideally. So, and sometimes you just want to know, is your application healthy? Not everything else too. And this is called liveness. And liveness is actually very cheap. It just proves that your app is still breathing, that it reacts to requests. And this should be relevant to process managers and to cluster managers. Because if this is failing, it means that your application cannot help itself anymore. It might be deadlocked, then it has to be restarted, or it just can't get up and needs to be rolled back in the middle of a deployment. Again, multiple common names. There's dash healthy, which is used by Prometheus, which I find personally very unfortunate because it's as close to health Z as it possibly could be. Then there's dash liveness from GitLab, and we've got Dunder LB heartbeat from Mozilla. Now this is interesting. The LB obviously stands for load balancer, which kind of indicates that Mozilla is using this endpoint for the load balancer health checks. And I have to admit, I do the same thing because they are much, much cheaper. And my resources, like my database pool, are lazy. So once my app is up, I can handle when the database is gonna break. And I can serve better errors than my load balancer. So my dash ready looks like this. This is like straight from production. There's no serialization, just quick plain text, no permissions, because you remember we block the whole dash namespace. And even if an evil hacker can access this yep, I can live with that. So you return a 200, you add it to your routes, and you're ready for load balancing. This is all it takes. And again, my database pool at this point, when this starts serving, is ready. It's initialized. So if it fails, I can serve better errors. If not, it's all good. So I do have a traditional expensive endpoint too, but I use that one for monitoring, and I call it much less frequently, like every 5 minutes or every 15 minutes, because I don't want to hammer our databases all the time. This is a classic trade-off. And one of the reasons why I chose this route is also because we use Nomad, which is also from HashiCorp. And unlike Kubernetes, which has both a concept of liveness and readiness, they have only one type of check. So I chose the cheaper one, the faster one. And I also really don't want my cluster manager to roll back my deployments just because our ops team restarted the database because of an update or something. Now, why stop here? We have an interface into your app. We can look right into it. We can write right into it. So what else is possible? So Mozilla has a Dunder version endpoint, so you get build information, which can be useful. If you use pull-based metrics like Prometheus, like I do and love, you can put them there. Again, you can easily protect them. Logging. It's always coming back to logging. Sometimes you want to get or set the log level at runtime because your app is misbehaving. But if you redeploy, the problem may go away, so you want to do it right now. And one common approach used to be to do it using Unix signals, like user 1, user 2, to just switch them. Well, that's not going to fly anymore if you're running in some cluster thing or so. So why not add an endpoint? And you can just post against it. So this is something that I've seen a lot, that people replaced things that used to be done using signals, that they are now done using web interfaces. Web endpoints. So now that we taught our app to talk to a load balancer, it's incredible how much freedom we have gained by this now, because you can now scale down and scale up as needed. It's magic. It's of course you can take this further too. You don't have to have them all on one server. You can distribute them over multiple servers. You just have to, listen on internal IPs. And the principle is the same. You have one load balancer that talks to the internet. the rest is in a private network. Now, once you do this and distribute your app over multiple servers, you run into a problem. Because they all have obviously different file systems. And while you can start using something like NFS or God forbid Samba and some locking thing, I would advise otherwise. So instead, I think it's again time to embrace the problem and rethink the approach we are doing here. And in this case, it's that the file system is lava now for you. So one classic file system thing, of course, is logging. We've solved that. We log to standard out. It's the environment's problem now. Other classics are state, like user sessions. They are not as easy because they need to be accessible from all instances. You don't want a user to be logged into only one instance of your app. So everything that is shared or permanent needs to go into other services. So no SQLite or no files for you. Instead, learn to love the Postgres, which is basically great for data of any kind to a certain scaling degree. So you can get away just with Postgres. But if you need something faster and more specific, there's Redis and Memcache, which are very popular and very good at caching and sessions. Things like Consul and etcd are great for dynamic configuration, service discovery, these kind of things. So when you look at it again, there's a second problem. Managing this is a pain. I mean, we are at 4 servers, but at 4 servers, SSHing around, of course, simple setups, you can get away with shell scripts or something like Ansible, and it's great if you can. But it can get complicated really fast, and over time, it accumulates. So let's get some help. Now, I'm pretty sure that I'm on the record of saying that Docker is kind of, I may have used stronger words, because Docker claims to solve problems it does not solve, and I stand by that. However, what it did is that it caused an industry packaging standard. It abstracts away even more application details, which for us as Python developers is great, because our packaging story is still not good. Like delivering a build fragment and a Python application is still a lot of pain. So those of us who work with servers, Docker was actually godsend, but not by itself. But it caused an ecosystem. And part of this ecosystem, of course, are cluster managers. And they indeed are game changers. Because once you get them running, which depending which one you use can take something bit of hours or months, you get into the position where you can say, this is my container, these are my hosts, run this container on some of those hosts, and I don't care how, where, or whatever you do. So you get fully automated deployments, and the work to get there is completely outside of your application. Because as I said before, those all understand environment variables, so they will configure your application appropriately. And your apps now become very ephemeral. They can have very, very short lifetimes, because maybe your cluster manager wants to shuffle them around. It needs to take nodes down and up again to, what I know, update something. Maybe it needs to rebalance itself because the load is not even. There's another reason for you to consider the file system lava, because some of them allow you to have something like a static file system that wanders around with your app, but it's still not great, and it's a half measure really. So I would just suggest embrace it. Don't have file system access. Well, your application is ready for a multi-data center cluster now, without knowing about it. All it knows about is how to start and communicate readiness, how to serve your application, and while doing so, communicate health, and how to stop when getting the right signal. That's all. So you are web scale by doing less. And now we could start talking about service discovery, service meshes like Linkerd or Envoy, Istio, but there's only so much time. But yeah, all these things you can only use if you've done the work in your app before, or did not do the work in the app before. Now, our final look at the app. Our application is still a black box that is easy to start. It's self-sufficient in getting up. It has a few varying options that are configured using the environment variables. We've got a clean shutdown using standard signals. It magically retrieves its secrets. We don't know how. It keeps its data in external resources like databases. So it moves along with it. It exposes its service. It exposes its service in a configured standard endpoint. And it also exposes a well-known endpoint for you to reach into the app. The logs still go to standard out. That's the same as on the first slide. It can be picked up by the environment or by your eyeballs on a terminal. It does not matter. Your app will never know. It just works. And for all of this to achieve, our web view hasn't changed at all. Our application creator now takes 1 or 2 class instances, one with the configuration and one with the secrets, and that's all. The interaction with the environment is limited to 1 file only, so it's, I'm not going to say easy to test, but it's realistic to test. And the same application works internally the same on your notebook, in a platform as a service, or in a cluster. And all the heavy lifting is either done by decades-old Unix tools, or by the bee's knees container orchestrator du jour. Now, success? One final thought. If you squirm at everything we said here, we want to see our application as a black box with clear interfaces that enable loose coupling with other components. We separate I/O from logic by logging to standard out, by pushing the configuration from the outside, and by transforming the configuration that comes from the outside into a class. We do isolate the process global state in one spot, and these are all best practices from software engineering in general. Especially it reminds me of the hexagonal architecture by Alistair Cockburn. So I guess the lesson here is that your application's boundary is just another boundary, and you should treat it as such. Your application is, or could be, part of something much bigger, and it should not care about that. But as with software architectures, what I've shown you here is an ideal, and not every application, of course, fits those constraints. Not every application can run in a cluster. I have plenty of applications that run on normal servers too. Someone has to write to a disk eventually. So, and some of what I say today conflicts with my advice from last year, which you may remember, our little recursive fun here. And neither is wrong. Yeah, but just present solutions to do 2 different problems, and you have to make the trade-offs based on your context. But to make trade-offs, you need to know the consequences of those trade-offs. So in other words, what I'm trying to say, you should keep inviting me and then make informed decisions. So one last thing, I promise. Don't we all crave realistic examples? Companies tend to talk about the operations, but they are not very concrete. They just use buzzwords about continuous deployment, chat ops, but in the end, it's usually just a bunch of shell scripts from 2002 written by an intern that is not at a company anymore, and nobody dares to touch it because it will break. Now, we do have a great open source example of a modern web application written in Python that I like to come back to. And of course, it's the aforementioned PyPI. You've seen the very impressive stats from Eva this morning. And everything you need to know, how to build it, how to run it, how it works, is right there on GitHub for you to look at. So that's all I had for you today. I would like you to check out the talk page. The QR code will get you there too. Follow me on Twitter and get your domains from Vario Media if you speak German. Have an excellent PyCon Belarus. Thank you.
Applause, please.
Oh, of course, feel free to come and talk to me. I don't think we have a lot of time for questions, but I'm here to talk. So,
yeah, we have a special speaker room that you can find later at the corridor. So, please, your questions, English or Russian. A few seconds, please.
thank you for the presentation. Okay, I do respect you. You're flexible enough to change your mind about the technologies with time. And I wanted to ask, what's your opinion about defaults in the application configs?
Defaults. Sorry, about the defaults in applications.
Yes, right.
I think the defaults should be in a way that they do the least damage. So that means like there's never ever gonna be the host name of my production database server in my source repo, or God forbid the credentials to it. So I can never ever accidentally drop database when I run my tests because some lines got screwed up. Also, if you have a debug flag that will just add additional information or something, it should be false by default. So I do not separate defaults by production and development, but by the damage they can do. And always go for the one that will just break your application, but will not expose your users' data.
Yeah. For instance, when it comes to secret data, it might be difficult to reproduce the full-fledged production setup locally. So, what would you recommend to do in this situation?
It really depends. I'm in a lucky situation. The only things I need to simulate locally is Postgres, SQL Anywhere. If anyone else has to suffer through that, my heart goes out to you, and Redis. And so that's no problem to run. I just for some of them, I have Docker containers because it's simpler, but I do have a 100% local setup because sometimes I just like to work at places that don't have good internet. So I always try to make sure that I can develop only on my notebook.
Thank you. Next question, please.
Thanks for your talk. And my question is the following. You mentioned that it's really vital to have supported the database structure between at least two nearest versions. Yes, I agree, it's absolutely vital. It's not a problem when you deploy multiple times a day. But would you recommend something, maybe tools or maybe best practices to handle it in more convenient, correct way?
You did just ask me about data migrations, right?
Yeah.
There's literally nothing I can say in my talk to prevent that. No, I'm sorry, I do not. So my problem is that we have few databases that are used by a lot of projects. So we have to synchronize it over multiple people anyway. And some of them are just like PHP, Perl, Python. So I do not have the luxury of having any automated tooling around it. I just have to suck it up. And sometimes, sometimes it's okay. Just say, okay, for 15 minutes, the server is going down. And we're just gonna do everything and then it's back. I mean, if you're wargaming, it's probably not what you can do because then everybody will hate you on the internet. But other than that, it's usually okay to be down for a few.
Thank you.
If the price would be like 2 weeks of concentrated work on a data migration, right? And just say, okay, 5 minutes down and then it's done.
We have one more slot for last question, and after that you will find Hynek near Coffee Point. Yes, am I correct? Will you answer more questions at Coffee Point? Okay, so last question here, Q. Sorry, please.
Thank you for your presentation. You used G-Unicorn as a runner for your application.
What do I use?
G-Unicorn. Yes?
Oh, yes.
Do you prefer it? How about UWSGI? Is G-Unicorn better or not?
Is this recorded? So, okay. I used to use UWSGI a lot in the past, and in my first talk I ever gave, I even was very positive about it, and I love the Emperor mode of it. where you can just it automatically reloads things. However, there is a lot of C in uWhiskey, and there's a lot of functionality in uWhiskey that you usually don't need. It's a very, very complex piece of software, and I have the feeling that sometimes it just starts falling apart, and it happens once too often for me, and that's when I just, okay, I'm going for something simpler. That's literally the reason. I think there's a problem when you mix threads and async IO, then it will just die in the add-exit handler or something. There's still a bug open for me, and they didn't fix it, so yeah.
Okay, thank you. Please, applause. You can catch